In this video series subset, we're examining 3 different hydrogen pathways in the HDSAM model. The subject of the first video was liquid hydrogen. In the second video, I'll look at compressed hydrogen gas transported via tube trailer. I'll review the scenario worksheet to identify the compressed H2 selection options. Then I'll walk through the structure and inputs of the 2 compressed H2 worksheets, and I'll close with a demonstration of the model. The HDSAM model incorporates economic data into the energy and emissions modeling provided through GREET to enable assessment of financial sustainability as well as environmental sustainability of hydrogen delivery pathways. In HDSAM, the gaseous hydrogen tube trailer pathway begins at a centralized gaseous hydrogen production facility, after which the gaseous hydrogen is compressed and transported to a gaseous hydrogen terminal. From the gaseous terminal, the hydrogen is transported via tube trailer to a refueling station, where the fuel is dispensed to vehicles. As I've shown in other videos, on the scenario worksheet in the model, we see the market demand selections, delivery mode selections, a refueling station capacity selection, and storage options. The selections for the compressed H2 via tube trailer pathway include the tube trailer option for the transmission and distribution modes, and geologic gaseous storage for the storage option. At the top of the compressed gas H2 terminal worksheet are tables showing the calculation outputs from the sheet, as well as energy use and emissions resulting from the process. The primary outputs in these tables are the compressed gas terminal portion of the delivered real levelized hydrogen cost, made up of contributions from capital cost, energy and fuel, and other costs, as well as system energy use and the terminal land required. The first inputs table is for compressed gas H2 terminal design inputs. The influential inputs here are the maximum and minimum terminal storage pressures, truck loading compressor flow rate, number of backup truck loading compressors, and isentropic compressor efficiency for truck loading compressor, number of days of storage at terminal, number of backup storage compressors, and isentropic compressor efficiency for storage compressors. The second table presents terminal delivery scenario inputs. After a table containing calculated values is the economic assumptions table. Inputs required in this table are compressor lifetime, storage lifetime, state taxes, and federal taxes. Next, there are a couple of tables related to capital investment. In the second of these 2 tables are required inputs for land cost, as well as other capital costs that include site preparation, engineering and design, project contingency, one-time licensing fees, upfront permitting costs, owner's costs, and other capital. The table that follows contains O&M costs. The significant inputs here include labor cost, storage compressor electricity consumption, truck loading compressor electricity consumption, electricity cost, insurance, property taxes, licensing and permits, operating, maintenance, and repairs for the compressors and for the remainder of the facility, overhead and G&A, and miscellaneous fixed operating costs. The remaining tables contain all calculated values. On the compressed H2 truck worksheet, the primary output in the calculation outputs table is the truck tube trailer share of real levelized delivered hydrogen cost, and that's summed up from the cost contributions from capital, energy and fuel, and other costs. And another output is system energy use. In the first inputs table, truck tube trailer design inputs, you'll want to specify whether or not to calculate the truck capacity based on tube, water, volume, and pressures. Other inputs include tube maximum operating pressure, tube minimum pressure, and tube operating temperature. The second table for truck tube trailer delivery scenario inputs has input fields for some time parameters. time to pick up tanker at terminal, time to drop off tanker at terminal, and time to drop off tanker at station. The other inputs in this table are average truck gas mileage, refueling station's location, and truck yearly availability. After the calculated values table is the economic assumptions table. The significant inputs here include tractor lifetime, trailer lifetime, state taxes, and federal taxes. In the following capital investment table, there are required inputs for the per unit costs of the tractor and the tube tank trailer. In the O&M costs table, the inputs of interest include labor cost rate, percent of labor cost allocated to tractor, percent of fuel cost allocated to tractor, insurance, property taxes, licensing and permits, operating maintenance and repairs, overhead and G&A, and other fixed operating costs. And again, the remaining tables contain all calculated values. For demonstration, I'll run the model with default inputs for a tube trailer pathway, and then I'll run a few scenarios after modifying some of the inputs to the tube trailer pathway and compare results to the default scenario results. For my scenario inputs on the scenario worksheet, I'll select urban as the hydrogen market and choose Sacramento as the city selection. I'll set the hydrogen vehicle market penetration at 4% and select the T&D modes to be tube trailer. The dispensing rate will be 500 kilograms per day, and the dispensing option will be 700 bar cascade dispensing. I'll select mid for the production volume, and I'll click to run the model. The first modification I'll make is to the distance from production to city delivery input on the scenario worksheet to see what impact that has on transportation cost. Before I make the change, I'll copy the cost results for transport on the results summary sheet to preserve the default result, and that way I can compare after modifying the input. The default total transport cost is 42 cents per kilogram of hydrogen. Back on the scenario worksheet, I'll change the distance input from 100 kilometers to 400 kilometers, and I'll run the model again. Checking the results, we can see that increasing the trucking distance increased the total delivery cost from $5.13 per kilogram to $5.73 per kilogram. And comparing just the transport cost, we can see that increased to $1 per kilogram. For the second modification, I'll bring up a new model workbook where I've already run the model with my default inputs. And for this modification, I'll look at the impact on greenhouse gases resulting from changing the electricity generation technology from the US average mix to the California mix on the compressed gas H2 terminal worksheet. I'll copy the default results for GHGs on the energy and GHG results worksheet. The result for total GHGs is about 24 grams per megajoule of hydrogen. On the compressed gas H2 worksheet, I'll change the electricity mix to select the California mix, and then I'll rerun the model. As a result of changing the electricity mix, total GHGs reduced to about 19 grams per megajoule, reflecting the lower carbon intensity of electricity generation in California. A couple of notes on the California mix. The first is that the emissions calculations on the compressed gas H2 terminal sheet refer to data tables on the GREET data worksheet. There was some data missing for California electricity mix that I corrected for this example. The second is that those emissions calculations were also including a reduction factor of 1 million for the California mix, but not the other electricity generation mixes. I corrected this as well. I expect these formulas will eventually be updated in the model, but until they are, be mindful of the upstream cell references when using the California electricity mix. For the third modification, I'll increase the costs for installation of major pieces or systems of equipment to see the impact on total hydrogen delivery cost. Again, I'll bring up a new model workbook with default scenario results. The total delivery cost again is $5.13 per kilogram. And I'll copy over the default results from the results summary sheet. On the compressed gas H2 terminal worksheet, I'll go to the capital investment table, where I'll change the user input installation cost factor values in column F. The default value is 1.3, meaning the cost to install the equipment related to the truck loading compressor, the storage compressor, and the compressed gas H2 storage is 30% of the cost to purchase this equipment. I'll change this value to 2 for each equipment category, so that the installed cost is twice the purchase cost. Then I'll rerun the model. I'll copy the new results from the results summary sheet to compare with the default results. And the costs increased, but only slightly. The total delivery cost is now $5.57 per kilogram, about a 9% increase. For the final modification, I'll increase the time to pick up and drop off the fuel tanker at the terminal to see the impact on total hydrogen delivery cost. I've already copied the results from the default scenario when I ran the previous modification, so I'll bring up another default scenario workbook and go to the compressed H2 truck sheet. In the truck tube trailer delivery scenario inputs table, there are cells to specify the time to pick up tanker at terminal and the time to drop off tanker at terminal. By selecting these cells, I can see that they refer to inputs on the scenario parameters worksheet, so I'll jump to those upstream references. And I'll double both of those parameters, changing the pickup time to 2 hours and changing the drop-off time to 1 hour. Then I'll go back to the scenario worksheet and I'll rerun the model. Copying the results over for comparison from the results summary sheet, we can see that increasing the pickup and drop-off times has had just a slight impact on our cost result, resulting in a 2-cent increase in total delivered hydrogen cost. So, to wrap up this video, I'll briefly recap the results we've seen through these examples. In the first example, I quadrupled the distance from the location of hydrogen production to my selected city, and that increased the total cost of transport by 137%. In the second example, I changed the electricity generation technology from the US average mix to the California mix, and that decreased total GHG emissions resulting from this pathway by 21%. Compared to the default results using the US average mix. In the third example, I increased the costs for installation of major pieces or systems of equipment by 70%, and that increased the total cost of hydrogen delivery by 9%. And in the fourth example, I doubled the tube trailer pickup and drop-off times at the fuel terminal, and that only slightly increased the total hydrogen delivery cost. That wraps up the in-depth look at the tube trailer pathway worksheets in HDSAM. If you're interested, you can view more videos about Argonne National Lab's Hydrogen Model Suite on the Hydrogen Model YouTube channel to learn more. Thanks for watching.